Gotcha. All right, let's go with it. Good morning. So we are getting close to 1.10, which is the last section here. Before we do that, let's go with any homework questions you guys have. Give me first section, like 1.5, and then give me the problem. Dylan, all yours.
I don't remember the exact problem, but I have to do one of this. 1.8, 23.
23.
Yeah, that whole set was like 13, 19, 23.
13,
It was always
19. Okay.
And
okay,
then,
cool. Go ahead.
after I brought like 45 and 47, 49, that's also like the same kind of problem.
Sure. Which section? Same?
1.8, yeah.
1.8. 40 what?
45 and then 47, 45.
Okay. Sure. Let's go with it here. Thanks, guys. And Isabel, did you have a question as well?
Yeah, 1.7.
Sure. You guys give me the whole list so we can cover all of them here.
1, 5, and 9. Actually, I figured out how to do 9, but I couldn't figure out B, C, or D.
Okay.
And I didn't understand what I was supposed to be doing for 1 and 5. So.
Gotcha. Okay. Yeah, let's do that. All right, anybody else? Going once, going twice? I'll go in order of them. And we go from there. For number 1, we were going to graph, let's see, graph when C is equal to -1, 1, and 3. So you're gonna put 2 graphs for each one of those pieces. Then just see what happens here. All right.
Graph it because we didn't have a number for X.
Okay. Yeah, let's do some just so we get started here. So this one is just for you guys to see the change in things on them here. So let me go 1.7, number 1, and then we're gonna go like this, 1A. And it says we are to graph f of x is equal to the absolute value of x plus c. And then it says, off to the side, it says, or part of the instructions, it says, let C be -1, 1, and 3. And so because we've done 1.6, we know at 1.7, the graph of just the regular absolute value of x would be, right? It's a V shape, is that right? It comes down as a V shape?
Yeah.
Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. 3 is 3. 4 is 4. So it goes this way. Then it goes absolute value of -1 is +1. -2 is +2. And here's our regular function. So now, based upon that, can you, and if you need to do numbers in there, that's fine. But really what you're trying to get is you're trying to get it to the fact that the C value. What's the C value going to do for you? Yeah, the C value at the end, this guy is our vertical shift. So let me change pen color real quickly here. I'll go with purple here. So if I was to graph f of x is equal to the absolute of x minus 1, talk to me. Where does it go? So let me put in the little values here. Now let me change the graph here. Yeah, so this guy only is going to make everything shift down 1 unit. We good? So once you get the parent graph, the rest of it's going to be pretty easy here. This is going to go down by 1, down by 1, down by 1 like this. And it's going to, so you have a graph that's doing this. The -1, 1 now becomes -1, 0. The -2, 2 now becomes -2, 1. And you have the purple graph. And we'll label it as f of x is equal to absolute of x minus 1. Okay. Does that help?
Yes.
Yeah. And I want to show you each of these pieces here. So you're going to do the 1 and then the 3 the same way. For B, 1B, the shift is going to be slightly different. Now the shift is, now the shift is inside the function here, so it's minus C inside here. So again, the parent function and again, you guys are going to do this on a sheet of paper with a grid paper. But you're going to go, what in the world is going to be this right here? So f of x is equal to x minus a -1, which just becomes x plus 1. Where does that shift to? Anybody? Say again? Not inside. If it's inside the function, if it was outside, if it was over here, there's our vertical shifts. But if it's inside the function, so if it's if it's absolute value, if it's squared, cubed, whatever, if it's inside the function, we got to go left. It's always opposite. Left 1 unit. So let me go change to purple again. So I'm going to go, a dot's going to be here now. And then it's going to be here and here. So it just shifted to the left 1 unit. And it went something like this. Okay, we're good there? And then C, it actually says x plus 4 already. And then you're going to add the C to it. Okay. Are we good there? So this might be like a homework catch-up day here. Number 5. Number 5 is probably... just to get you guys started, this is 1.7, number 5. And see if this makes sense. You have to look down on the homework, and you have this little graph right over here. And so same thing, the graph says these little dots there. It goes like this, it goes like this, it goes like this, and like this. So the coordinates are 0, -1. Next one is 1, 0. Next one is 3, 1, and then 4, 2. So it kind of goes like this, it goes like that. And then let me change the pen color on that. So let me go like this. Then it kind of goes sideways a little bit here, and then it goes back up. Slightly bent line here. Boom. So what we want to do is that's the original f of x. So for A, 5a, what I want you to do, based upon that graph, can you graph for me the original function plus 2? And this one's really just trying to gauge you into what are you doing? How are you manipulating each of the pieces or each of the coordinates? Are you messing with the x or are you messing with the y? Are you adding, subtracting, or are you multiplying, dividing? What are you trying to do there? So kind of gets you a little piece there. So let's do, I'm going to just start with A and B. And then if you guys have any further questions on 1.5, just ask me on Friday. We'll go over those if need be. Okay, so this little guy right here, on the outside, it is a vertical shift again. So if you're talking about vertical shifts, you're talking about moving the y values, right? Y values get moved. So in this case, we're going to move it 2 units up. So that's 0, -1. I need to do 6 here. Okay, and let me switch color. So that little 0, -1 now became 0, +1 because we technically have added 2 to the y values. We good? And so we technically, what we're doing is we're just adding 2 to each one of these right here. All right, so this is now 1, 2. This is 3, 3. Let me put in the x. 1, 2, 3, 4. Yeah, there we go. All right, and then 4, 4. Now that's where we're at there. So again, it's the same shape. Notice it does the same thing. It goes like this, like that, but now it's just 2 units higher. And then.
I think the question for G is it's trick, but it's like f of like 1/2 x. Why does that make the x like double?
Oh, sure, absolutely. Good question. That's probably the more difficult ones there. So let's go with 5G. So we have our y value, and it's 1/2 x. And let's do this. This is a good time for an explanation on it here. Let's do an ordinary function. Let's call it, x squared would be easy enough to sort of see, right? So let me explain that little piece there, because that's always difficult to see here. So if we have x squared, this would be 0, 0, 1, 1, 2, 4. This goes the other way. So here's our x squared function. Da, da, da. Okay, so if I were going to change this up and I was going to put a 1/2 inside here and put x squared like this, let's graph that one. And I'm going to change the color just to see it here. So 1/2 x, there it is. Okay, so let's plug in some points. If you plug in 0 into here, whoa. This is x, sorry, this is x, this is y. If you plug a 0 into there, 0 times 1/2 is still going to be 0. So if you square it, it'll still be 0. So that little 0, 0 point does not change. That's still the same. So if you plug in a 1 into here, what's going to happen is you're going to plug in a 1 in here. This would be 1/2. And then you're going to square 1/2, which will give you 1/4. Good there? We'll get to the 2 in just a second here before we plot it. If we plug in a 2 into here, 2 goes into there. And it becomes a 1, and 1 squared is 1. So let's see how we plot this. So at 1, it's going to be 1/4. At 2, it gets to be a 1. So if I were to graph this out, it goes like this. In fact, it's actually even wider. So notice this particular point right here and this particular point there. So the explanation is this: as you go out away from the y-axis, right, it takes you twice as long to square what you normally would have done is at 1. So if you was to square 1, 1 squared would be just 1. But now, if you plug in a 1, you're only at 1/2. And so it takes you twice as long to start squaring 1. Does that make sense? Maybe, okay.
How does that translate to the graph?
We'll do the 5G in just a bit here. Okay, so just want you to kind of realize this. So if you get to 4, if you wanted to get to 4, you have to square 2, correct? But you got this little 1/2. So everything is taking twice as long to square. So 4 would be the thing you have to plug in to go down to what? 4, half of 4 is 2 squared, and now you get to 4. So in order to get to here, you have to be all the way out to the 4 marker to get there. So this one actually should have been even more wider. It would have been like that. So everything is taking twice as long to get there because everything's slowing down by 1/2. It's just slower now. As opposed to on a vertical stretch, if you're stretching things, it just the bigger the number, the faster it goes up. Notice on this one, the lower the number, which is with the 1/2, the slower it goes up. Okay, so with that, let's go with the numbers themselves. Original, if you guys are looking at the original one right here. So each one of these now if you plug in the 0 marker into here. So first of all, we should notice that we're affecting the x-axis here. Is that right?
Everything basically just get like twice as long.
Yeah. So everything is pushed out this way by a factor of 2. So everything is twice as we say, twice as wide away. So just like, and another further explanation, if you guys want to sort of see it here, notice that on this one, it always goes the opposite of what it's trying to do, right? Inside the function, if you're adding, you're moving to the left, right? If you're multiplying technically by its reciprocal. On the outside, if you have a -1, it makes sense. You're just going down, right? If you're doubling, you're multiplying by 2 on the outside. But on the inside, all the functions work opposite of each other. So
X minus 2. Right?
sorry, let me get my little 4, 1, 2, 3, 4, 5, 6, 7, 8. That's what we're going to be at. So on this one, Annette, if you're here, let me go back to the previous one. If you're here, 0, -1, it's going to stay because it's not moving away from the y-axis. That number is still the same. So this is still 0, -1. 1, 0. So if everything is taken twice as slow to get there, right? 1, 0 gets translated to 2, 0. Okay, we good there? And at 3, 1, now we're at 6, 1, right? Because everything is 3, 4, 5, 6. Now we're at 6, 1 here. And 4, 2. So then you notice that what happens is we're just doubling. So we're just multiplying by the reciprocal of whatever's inside the function. And 8. 8. Was it 2 or 3? It's 2. 8, 2. So here's my connection now. It goes like this. Then a slight turn. And 8, 2 is right here. So then it turns up a little bit. Okay, does that help? So if it's addition, subtraction, it's the opposite. If it's multiplication, division, it's the opposite function or the reciprocal. Okay, we got 1, 5 done. Oof. And 9. All right, for number 9, this is 1.7. For number 9, based upon this equation right here, so x squared. The question is, write the equation for a. So all right, and you guys have to help me out here. That is a very bad graph for boom. Okay, so how does x squared compare to this graph here? And Isabel, A, B, C, or D, any one of them gave you more trouble? I think you said B, C, D, right?
Yeah.
Yeah, let's try those here. Let's do A first. So you guys talk to me here. What has happened from the original x squared to this one? To this one right here.
I had GX equals x squared minus 1.
Yeah.
Yeah, everything got shifted over down by 1, right? It was a vertical shift of 1 down. And so then the equation then should be x squared minus 1 because everything just got shifted down. We're good? Okay, cool. So that's A. Let's go down to B now. So now we have to think about, hey, you know what do I do to x squared to eventually get me to this little function right here, to get me so that I'm at negative 1, 1, and I'm going down like this. What?
I figure out what happened, I didn't know how to write it in the equation.
Okay.
Because I think it's an inverse and then one to the left, one up, and to the left.
Uh-huh.
I got 1 minus x plus 1 squared.
I got negative x plus 1 squared and then plus 1.
Okay.
You probably won't.
Let's go for it here. So first thing we notice it's a flip, is that right? Notice there's a flip there. So let me write it as a function itself here. This guy is x squared originally. So first thing I noticed that there's a flip on my hands here. So that means I have a negative in front of x squared. Good there. Then I noticed that there's a shift to the left. Shift to the left would be x plus 1. Abe said that here. So that means I got a negative still in front, but now I have x plus 1 squared. We good? Then I also notice I have a shift up to this little, very important, called vertex. And that means I have a vertical shift of 1. So that means it has to be negative still on the outside, x plus 1 for the going to the left, and then I have 1 going up.
So mine still works then, right?
And you had what?
I have 1 minus x squared, x plus 1 squared. And you just put the 1 in front.
Perfect, that works just perfect. Dylan, is that what you guys, what you had? Cool, so we're good now? Okay, let's move on to some tougher ones here. C, I got this little graph. So original graph. And final graph. Dun, 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 dun. So 6, 2 looks like is the important point here. Or sorry, 2, 6. 2, 6 is the important point, and then it goes down like this. Okay. So still, I think once you get B, then you get the rest of them pretty easily. So upside down again, is that right? So f of x is equal to x squared, now becomes f of x is equal to negative x squared. All right, what's the horizontal shift? It's 2, yeah, 2 to the right. So how about x minus 2? Perfect. And then how much do we go up? Perfect. Okay, boom.
Basically just find a new origin, wherever that is. And then take the coordinates and put it in there.
Oh, awesome. Okay, good. So we have, as long as you know what the vertex is, yeah. So they could trick you and not tell you what that is and stuff like that. But yeah. So notice it's always the vertex is the opposite. So it's almost like negative h, should we say? And this one's k. So the negative just means we switch the sign on our value there. Perfect. And in fact, that's this is called the graphing form of a parabola. If you have it in this form, called the graphing form, it's so easy to find what you need to graph, and then you just go from there. Okay, D. One more with D. It's just a little tricky because it's off-centered here. So, boom. And then we need to go to this one right here. So then you got to look a little closer here. It's 1, 2. This goes up by 2, so 2, 4, 6. And it's like right there. Is that right? Right there. Two. Oh, I made my values here wrong. So I'm going to go like this and like this. And then I go like that. Okay, so f of x is equal to x squared. That's fine, initial function. No reflection this time. So now really, as Abe was saying, I just need to find this point right here. So what is this darn point right there? 5 is true. And these guys go down by, oh, you know what? They actually give you, they're trying to trick you. They give you that and that up on top, but they don't give you those on the bottom, right? The tick marks, they don't tell you what the tick marks are on the bottom. So then you gotta like, oh, okay, I know what that's that. So therefore it has to be 5, -3. So what we've done is we have went to the right 5 units, and then we went down 3 units, and there. Okay, are we good there? Good question. Those are really good questions to go through. Something didn't cover as thoroughly on the lecture, but still good. Okay, jump to this. 1.8 is where we're at. Let me see them. So 13, 19, 23 is the first type, right? Evaluate the function, blah, 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 and blah, blah, blah. And then 40, let me just kind of take a look at these here. 40, 43, no, 45, 45, 47, 49, and those are a little bit different. So 45 we should do, and then one of these guys here. Let me just pick out what I want to do out of this one. Let me do 13 and then 23. You guys okay with that? And then 19, I'll let you guys try by yourself here. So 1.8. 1.8 homework. And number 13. So let's go through this here. So evaluate the function if f of x is equal to x plus, oh, sorry. Let me rewrite this one. Define f of x first. F of x is x squared plus 1. G of x is x minus 4. So what f does is squares a number and then adds 1 to it. G of x, it subtracts 4 from that number.
This is 0.3, right?
13, and then I'm going to do 23. We'll do the easy one first, and then we'll do the more complicated one. So we want to find out this. We want to find out the addition of these two functions together, evaluated at 2. So what happens if I put these both functions together, and I want to find out what x equals 2 would be. Cool. Okay, so before we even get there, what we have to start off with is I got to figure out what the function itself would be. So what would be f plus g of x? That's what I'm looking at first. So this one just says, okay, hold on. I'm going to add the f function with the g function. That's what I'm doing here. And so that means this is this plus this right here. And I'm going to create a function that does both of that work at the same time. So drop parentheses. Add it together. So 1x squared over here, I have an x. And 1 minus 4 is a minus 3. Voila. So I have created the generic function f plus g of x. I can write it down here. I'm going to write it just, you don't have to write it. I'm going to write it so that it gets me, at least show you guys what it looks like. So there's my generic function right there. What I'm trying to find is what happens at 2. I'm trying to figure out this right here. In this case, we're just going to plug in a 2. 4 plus 2 minus 3 is 6 minus 3 is 3. Everybody agree? Say again?
You just plug in the 2?
I just plug in the 2. After
You're multiplying everything. It's f of x. Okay.
Cool. Yeah, so this is just same thing as, same thing as f of x or f of 2 or g of 2 or whatever it is. Okay, are we good there? Okay, 23 is the toughie. I'm sorry, 23 is the toughie here because it wants you to do a few things here. Hey, did you say this here? You could just plug in the 2. Is that what you're saying? Okay, so this is the proper mathematical way of doing it. We good? Now let me tell you the shortcut. Here's a shortcut. Go back up to here. And what this means f of 2 plus g of 2. Is that right? So instead of making a generic function first, what we do is we go back over here and say, you know what? If f of x is this, what would be f of 2? Oh, that's going to be 2 squared, right? Plus 1, which makes, let's see, 2 squared is 4. 4 plus 1 is 5. So we bring down the 5 into here to replace the f of 2. We good? Let's jam over here. Now we need to know g of 2. So let's go over here real quick here. If g of x is x minus 4, that means g of 2 would be 2 minus 4, which is negative 2. And we're adding these two functions together. And what do I get? 3. Oh, look at that. It's the same thing. Cool. So hold on. So that means I don't need to create a generic function all the time, right? If I'm just looking for one specific piece right then and there, I could just plug in that one specific piece into the first function, second function, and put it all together. We good? Okay, so now let's do 23. Actually, no, let's do 19. I'm going to just do 19. Okay, 19, here we go. Fg of 6. Let me write down what that function is, and that's what this function is. Boom. All right, you guys talk to me here. What's the operation between f and g?
Multiplication.
It's multiplication, absolutely. Since there's no space between the two of them, this means this. This means f of 6 is being multiplied with g of 6. Now, do we need to make the generic function, yes or no? No, it's the long way, right? The shortcut way is just to find out what the values are. So off to the values here. If I plug in a 6 in here, answer is anybody?
37.
37 is perfect. It's 6 squared plus 1 more makes, I should put it right here, 36 plus 1, 37. Perfect. I'm going to plug in 37 right there. Go back over here. I need to find g of 6. Everybody okay with 2? And final answer, 37 times 2.
74.
Da, 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 da. Okay, we're good there. So don't need to create a generic function if you really don't need to. Okay, 23. Let's do this one here. Same section, 23. And those that have not done it yet, give you guys like 20 seconds. Try it yourself first real quickly here. There it is. 30 seconds. I'll give you guys 30 seconds here. Try this first. So I want f divided by g of negative 1 minus g of 3. And with this addition and subtraction of functions here, we use this so much in the real world, especially when you know one formula for one thing, you know formula for the other. And so we plug in formulas all the time. So engineering, if you know the pressure of a capsule or how fast it's changing, then you also know the density of the liquid itself. We fuse those together to give us how much the density is changing. So a lot of different ways to do that. All right, let me plug it in. Let's see what happens here. So this one's gonna be a little bit tough one here. So this guy is gonna be f of negative 1 on top, g of negative 1 on the bottom. We good? Because that's what this means. Then it's gonna be subtraction of g of 3. Okay, so off to the side, we're gonna figure out what is f of negative 1, and tell me when you guys know it. 2 is good. Okay, now I need to know g of -1. I'll go with that. Then I still need a third one. I still need to know what g of 3 is as well. Ah, didn't put parentheses there. I like usually putting parentheses there. 3 minus 4 is -1. Okay, so now I think we got what we need here. Dylan, good.
Where did the 4 come from?
Where did the 4 come from? From here.
Yeah. Where's the function?
G of x is x minus 4, right there. Good question. That's good. Rather you guys ask me what things. This is exactly what I want you guys to do. Like, hey, where'd that 4 come from? Where'd the 12? How'd you get the 7? Okay, so I have a 2 on top, -5 on the bottom, minus a negative. Don't forget the minus there. It's a minus -1. So I don't like negatives on the bottom of fractions here. So we can either put in front or on top. This will be a +1. Common denominator is? Thinking I have 5 as a common denominator. Are we good? So that 1 changes to 5 over 5, and voila. How about a 3/5? Is that what Bob says? Who is Bob? We're back of book, yeah. So Bob is pretty cool. Bob is a pretty cool mathematician. He gets almost everything correct. Okay, finally to this one over here. Abe, you had what, 45, 47, 49 or no?
Yeah.
Okay, and we'll probably have just enough time to do that one here. Are we okay with 23 now, guys? Okay, this is 1.8. Number 45. Okay, this one is composition of functions now. It's this times this, or not times, but it's this. It says use the graphs to find out these things here. So the graphs, kind of be careful here because we have, it's an absolute value function. Oh, sorry, at 2. So it actually goes like this. Sorry, 1 second, let me scratch that out. Oh, you know what, actually, let me see if I can erase it. Oh, good. I like erasing. Okay, this is this. And got about 3 minutes here, so I think we can do this here in 3 minutes here, like this. That's my first function. It intersects at 4. That's my f function. My g function is just a straight line. It comes down like this, starts off at 4, and we have to pinpoint all these points here. So at 1, it's 2. At 3, it's 2. And at 4, it's 4. So got all these points here that you should recognize. And the g function, 0, 4, 1, 3, 2, 2, 3, 1, and then 4, 0. So you've got all these points you should recognize here. So 0, 4. 4, 0, and the middle points are 1, 3, 2, 2, 3, 1, and go on. Okay, so what does this mean? Here it is. This guy, talk to me, anybody. What does that little symbol mean? Say again? Compose with. It means that the g function is inside the f function. And again, this is something new to you guys here because we have not seen this in Algebra 1 here. So what we're going to do is we're going to figure out what is g of 2. And for g function, we've got to look over here. So if I look at g of 2 input, I get an output of 2. We good? So eyes on this one right here. So g of 2 gives me a 2. If it gave me a 1, I would be doing something else here, but it gave me a 2. So now I go to look at this function. Says, okay, hold on. So the input for 2 gave me a g value of 2. Therefore, the input of f of 2 will give me a value of 0. Is that right? Because this is 2 comma 0 right here. So you're kind of going to one function, you're talking about the input, you get the output value here, and use that output value to do the input value of the next one. And then Dylan, you had the other one, right? This one would be real quick here. With 50 seconds left, I think we can finish it. For 47 to 54, you're going backwards. So what you want to do is you want to look at this function. Once I do this problem, I think the rest will be easy. You're going to separate these out. What does one function look like it's inside another function? What do those functions look like? So I see, especially when there's parentheses, you can kind of tell. So notice inside the parenthesis, you have this little guy right here. So I'm thinking, you know what, g of x, the inside function is going to be 2x plus 1. What? Good, and f of x is x squared. It's taking this whole thing and squaring it. So the f function is the outside function, it's squaring things. G function is the inside function, it's doubling it and adding 1. So now we're separating those out. Now, there could be, you could separate those out a little bit differently here. So real quick here, you could have done it like this. G of x could have just been doubling only. Are we good there? F of x could have been adding 1 to it and then squaring it. So there's multiple correct answers here. We're good? But you're just trying to separate the two functions from each other. That's what you want to do. Okay, and class is over. Thanks, guys. Was that helpful to go over the homework and all the good stuff here? Yes.
Thank you.